Good morning, everyone. Enthusiasm, huh? Woo! Yeah, that's better. How many of you here do Android development? The rest of you are just lost or something. Okay. I don't do Android development, which is surprising why I keep getting invited. But thank you for having me. That meant that the last time I came wasn't so bad. So, can I get my slides here? Oh, they are there. Okay, great. We're good. Okay, so Silver Bullet Syndrome 2. How many of you have seen Silver Bullet Syndrome 1? Okay, great. 3, so I can repeat all the same jokes. Brilliant. So this is a sequel to the Silver Bullet Syndrome. Now, if you haven't seen the Silver Bullet Syndrome, you may be asking yourself, what is that one, right? I got a problem with the clicker here. Apologies. So let me just... And this keynote is in German. And it's not even keynote, it's PowerPoint. Okay. There we go. Okay. Yeah, okay, we're sorted. We're good. We're good. Right. Right. So, Silver Bullet Syndrome sequel. Okay? Now, you may be asking, first of all, who's here to learn? Okay, so this is going to be a really, really disappointing talk for you. And in fact, when Greg said that I'm going to answer some questions, I'm not answering any questions. And I timed this perfectly and exactly so that there is no Q&A, right? So what was that talk about? Well, that talk about was me essentially ranting at the IT industry, right? That's essentially what it was. Now, the good thing about this industry is that it just doesn't stop giving. So there's always something to be ranting about. But as with many sequels, there's a risk, right? That, you know, sometimes you see a good movie, it's great. You see the sequel, it's crap. That's happened, right? The only exception to that is TED 2, which I love. I think the TED 2 was way better than TED 1. So I look at this more as a director's cut. That way I can repeat the jokes. It's kind of like maybe the ending is different. But let's take a step back before we do all of this and ask ourselves, why are we here? I also find it especially funny that the second reason why we're here is just to suffer. Right? Some people, I think we need as a human race to be a little bit more optimistic. Comes from me, the most pessimistic person in the room probably. But what are our objectives in technology? Is it to solve interesting problems? Who's here to solve interesting problems? Okay, I've got a slide for everyone else. Don't worry. It's this one. Who's here to make boatloads of money? Good portion of the room is honest. Is it to automate everything? That's kind of where I started. I started with the whole thing of like, oh, I want to automate some stuff and keep track of some stuff, and I started to fall in love with that. And then that ended up like saying, oh, if I could automate stuff, I could also end up helping people to solve their needs. Now, talking about solving needs, if we look back at the year 1990, there was a fellow that wanted to create a system for managing docs. And for that, he created a protocol, which was called HTTP. He then created a markup language, which was called HTML, and then a browser, because back then there wasn't such thing as a browser, and he also created a web server and a website. And this was basically for him to manage docs. Now let's fast forward 30 years later, and you get things like, our system consists of a distributed set of microservices that talk to each other using GraphQL. Messages are stored in ActiveMQ, and using Kafka as a fail-safe option. We use serverless technology to calculate data which is stored in Redis. We're looking at adopting blockchain. That's where we are. Why? Nobody knows. But that's where we are. When I retire from this industry, I want to become the Gordon Ramsay of this industry, where I go around and just say to people, why are you doing this shit? Right? And I tweeted that, and someone said, oh, have you looked at the results of Gordon Ramsay's restaurants? They weren't very successful after he left. I said, I don't care. I'm not there to try and help people. I'm just there to rant. So if anyone's interested in that program, let's hook up and make it happen. But back in the day, I used to also work on websites. I started like in the, after doing desktop development, which apparently died many years ago, but it's still there. I started with the web technology, and I was working at ISP where we were basically creating websites to have people. I live in the south of Spain, Malaga, so the only industry there is tourism and selling property. And we had a crash in 2008. Another one's coming, but it doesn't matter because 2008 was a long time ago. So we used to sell, there was a lot of real estate, and they used to they used to fax us, or well, not fax, email us their list of properties, and we had to put it on a website. So we decided to create an application. Back then, to create application, does anyone know what this logo is? What is it? Dark side of the moon. And you may be wondering, what's that doing with web applications? Well, it turns out the CGI logo was the same thing, with the word CGI in. And if you're not familiar with CGI, that means Common Gateway Interface. And it was the way to create applications, web applications back then. You basically had a Linux system mostly. You had an executable. You would talk to that executable and get some results and render that page. And more efficient versions came up, such as ISAPI DLLs, NSAPI, which was a dynamic loaded library on the Microsoft platform. And the benefit of that was that whereas with CGIs, for every single execution, you needed to load the application, execute, and unload it. With the DLLs, it stayed in memory. So it could serve more with less memory. But the idea was very simple. You took a browser, you would talk to a web server, do some stuff, render some HTML, talk to a database, render some HTML. That's how it used to work, right? Nowadays, they call it server-side rendering. Like back then, that's all there was. And then, of course, came scripting and JavaScript. Now, when JavaScript came, it was quite complicated. That's funny. It was quite complicated to understand, as if now it's simple. So nobody really understood JavaScript. They understood jQuery. Like when you say, do you do JavaScript? They're like, no, I do jQuery. jQuery was great. It was a really easy library to kind of like, you just add it. It's very small, and you can do a whole bunch of things. And people started to say that refreshing this whole page is really, really crazy. It's just crazy that I have to constantly refresh this page over and over again to get some interaction, to get some usability aspects. So what we came up with was this idea of a single-page application. And then, of course, AngularJS 1 came out, and then AngularJS 2 came out, which had nothing to do with AngularJS 1.0, but apparently they use the same name. And then there was a whole bunch of people that said AngularJS is crap, so we're going to do another thing. We're going to call it React, and React is a much simpler programming model. It was called the Flux architecture. Some folks said that's not a simple programming model. We're going to go with Reflux. Didn't find a logo for that. So that's the closest I found. And then, of course, all of this came accompanied by a very simple model that used to exist back in the old days, which was called, with Smalltalk, which was called Model View Controller. You had a model, you had a view, which was what you wanted to display, and you had a controller that basically talked to these things. But MVC wasn't good enough, so we had MVP Presenter if you're doing kind of like desktop application. And then that wasn't great, and then Microsoft said, no, we're going to do MVVM. And then someone said MVVM is no good, we're going to do MVI. And now you've got frameworks like Vue.js, and people are starting to say, well, this single-page application is giving me performance issues, right? Maybe if I could just get the server to render some stuff. So now we have articles where it says, why use server-side rendering to boost performance and user experience? There you go. So we went through all of this phase, and it's good. You say, yeah, it's good. We're learning. Yeah, you know what we're also good at? Making the same mistakes. So that's how we used to do it. So now I've got a website. This is a website for KTOR. How many of you have heard of KTOR? Okay. The rest of you, you need to stop what you're doing and start doing server-side programming with KTOR. So KTOR is a website. It's basically static. There's not much dynamic stuff in there. And I talked to the web team, and I'm like, so what technology are we using this month at JetBrains? And they're like, oh, Gatsby. OK, great. I'll do the site in Gatsby. And so I've got a really, really awesome website in Gatsby that is just static. And we'll come back to this little jewel over there. And this hasn't been updated for quite a while. And if you look at every application we do, we basically create applications, we create data, we read it, we update it, and we delete it. What is that? CRUD. But you don't go around saying, I do CRUD, because it's demeaning. Like, really? Your life is basically a pretty user interface to a database? That's what you've done all your life? No, I don't do CRUD, right? But, for that CRUD, we used to write some code. We used to write some code that would create some code that would update, some code that would delete, and etc. And then we repeated that code, and of course we say, well, repetition is evil, and we should always be dry. And don't repeat yourself, not in the other context. And what we did, we started to write some utility functions, and we said, well, this is going to work great across my one application, but now I need to put this across multiple applications, so I wrote a library, and it wasn't enough. No, because there's a mismatch. What was the mismatch? Well, we had this thing called SQL Server, or any kind of SQL model. And then they always taught us at school and university and wherever, in kindergarten, that the world is objects. And you have to think of the world as objects. And you're like, but I've got this relational model, and I've got this object model. What am I going to do? What we do best, we write a framework. And we called it an object relational mapper. And it was fantastic because it introduced so many benefits to us, right? And the great thing that it was basically mapping objects, object model to a relational model, but that didn't stop us from using it with document databases and bringing in other document databases and saying, oh, where's my ORM for DocumentDB or for CouchDB or for MongoDB or whatever? We started to say, no, we need to do the same thing here. But then someone said, oh, my ORM is giving me issues, right? Because every time I'm making a request, it's loading a whole bunch of stuff that I don't necessarily need. And they said, well, the problem is that you're designing things incorrectly. And thus came the big divide. That divide was called command and query responsibility segregation, right? Who's heard of CQRS? Which basically means separate your reads from your writes, Create a function for creating stuff and updating, and another function for reading, like what we used to do, okay? When it came out, nobody understood what it was, so when you used to Google it, Google would say, did you mean cars? Right? Because they didn't understand what CQRS is. That's where that slogan from that blog comes. And of course, this was actually done by Greg Young, who at the time was also doing this other thing called event sourcing. And they said, oh, if you're doing CQRS, you've got to do event sourcing. And it didn't help the fact that, when you would go to the website to learn about CQRS, it was also from a company that's called Event Store, which does an event database. And then people thought, well, if I'm doing CQRS, it only works if I'm doing event sourcing. Do you need event sourcing? No, but it sounds really cool. I'm just going to do it because that's the way you do it. And then they said to you, but you can't do any of that. You can't do CQRS, you can't do event sourcing if you don't learn about domain-driven design. But all I'm doing is some CRUD. No, you need to learn about domain-driven design. And there was this book by Eric Evans, which is a great book, and the majority of people took one chapter from it, which was the repository pattern. That's it. By the way, the other day, someone pointed to some source code on in the Android libraries that was called a repo repository, which is apparently a repository for repositories. And so we got, hexagonal architecture and domain-driven design. Let's bring this idea of a hexagonal architecture and have these layers, and we need all of these different aspects, right? And then we ended up with the onion architecture. This is not a joke. We ended up with the onion architecture, and then some companies that maybe sell tooling, they're like, oh, this is really cool because I can basically tie in my tooling offering with DDD and CQRS and Event Store and all of that stuff, and it's absolutely fantastic. So they're like, we took a simple idea of reading and writing, and we went through this whole phase, and then we're like, no, let's go back to that, but you can't go back to that in a simple way. You've got to add a whole bunch of complexity. Then, of course, they tell us that the architecture needs improving. Back then, we had the CGI. We had a single executable. Now they say you need to have multiple executables, right? And as Simon Brown said, that if you can't build monoliths, microservices aren't going to help you. So essentially, if you've got this, you're going to end up with this, right? It's just not going to work. And of course, if you're doing microservices, you don't just do microservices because nobody does an HTTP endpoint returning JSON. Well, they do, but they call it REST. And it has nothing to do with REST, and no one's read Roy Fielding's dissertation about REST. They just said, oh, pretty URLs, with JSON. I'm doing REST. And then someone says, but REST is crap, right? But it's only pretty URLs with JSON. I'm not using all of the other benefits of REST. It doesn't matter. It's crap. REST is too hard. So what we can do instead is, instead of leveraging HTTP, which is a protocol that's existed for, what, 40 years, and, use status code and everything like that, no, we'll do 200 OK and start going into GraphQL territory. And then get us to basically do everything with GraphQL. So now my beautiful little website for KTOR has a GraphQL database to access images, which is fantastic. And a lot of this, of course, requires building. And talking about building, you used to have some source code. When you had that source code, you would put it through a compiler, and it would compile something, generate some intermediate language that would go through a linker, which would then give you an executable. Now, that was hard. It was easy, but to do that, you had to invoke the command line. I know a lot of folks don't like command lines, but we had to invoke the command line. Now, when you would type, for example, make or whatever, or compile, you would get a whole bunch of options. That was kind of tedious, so there was a new build tool which was called make, which some of you may be familiar with, which tried to kind of like make that a little bit more optimal. And then, of course, we got Maven in the JVM world. Microsoft got MS Build. Then someone said, oh, that's all XML. We don't like XML. Who likes XML? I do. It's XML, a descriptive language that tells you exactly what it's doing, but screw it. Instead, at the time, there was also another tendency in the world which was called Ruby, and Ruby on Rails, right? And Ruby on Rails was this like convention over configuration framework for creating applications in a really rapid way, and it was fantastic. And then Ruby said, well, I'm going to take the Ruby language and create this thing called Rake. So, what did we do? Well, we got Cake in the C# world instead of MSMA. F# got Fake. And what did JavaScript get? JavaScript, of course, got Jake. But JavaScript also got Grunt, Gulp, and of course Webpack, which I tuned in yesterday, and apparently there's this drama going on in the JavaScript world because someone said Webpack is crap, and they're coming out with something new now. But it's fantastic. We also got other things, right? We also said, hey, this is a good idea, this whole, take this descriptive, beautiful language and try and describe your builds like that. We got Gradle, right? How many? Never mind. So, Gradle says, well, instead of doing all of this ugly XML, what we're going to do is condense it down to something really, really beautiful in a file, or maybe 2 files, or maybe 3 files. Or maybe a few more files. It doesn't really matter, right? And you no longer need to really describe what or how you do it. You just say what you want. Now, in order to figure out what you want, you read the 65 chapters of documentation and understand the underlying principles of Gradle, which nobody ever does, right? We all go here, right? This is our life. Okay, file, new project, Gradle, script generated, anything else I want to do, Stack Overflow. And of course, if you're using IntelliJ IDEA or Android Studio, you're going to have to do this one as well. So at JetBrains, we also adopted Gradle, right? And how many of you do Kotlin multi-platform projects? Right, so the rest of you should. Any iOS developers here? Cool. So Kotlin multi-platform is a very simple idea. It's basically share code, save time, right? Now, the idea is that you write shared code, you write code that you're going to be repeating on multiple platforms, and you save yourself the effort, you save yourself the time, which is fantastic, right? Because then you can dedicate that time to more meaningful things in life, such as enjoying your work, enjoying your life, enjoying your hobbies. No, instead, we'll get you to configure Gradle. All of that time we're giving you back, we're asking you now to figure out why your multi-platform project doesn't work because Gradle. Okay, yes, we've really, really screwed up on this one. So, now talking about configurations, we have XML sucks, remember? XML sucks. I mean, 2 people put up their hand, one of them was me. So everyone thinks XML sucks, so we said let's use JSON instead. Because JSON is more readable, right? It's more concise, it's more readable, it's clean, it's wonderful. someone said that JSON isn't human readable for some reason. So they came up with this other thing called YAML, which is way more readable. Way more readable, right? And it's a simple language. It's, it's very easy to understand. It doesn't have complex grammar or anything like that. And it's way, way more readable, right? But of course, what happens when something like this happens? Someone else comes and says, no, YAML sucks as well. So I'm going to go with TOML, right? So TOML, by the way, YAML has now been adopted by Gradle, I think, as well. Anyway, TOML sucks. TOML is so much better, and I think Tom, that invented it, and a few other folks are really happy with it. Now, why? No, because it's human readable, but first of all, who spends their life reading JSON files? Like literally, do you really spend your life reading JSON files? No. When you want to change something, you go search, find it, and change it. It's like, no, let me read this as a book. Let me go through chapter 1 again. Yeah? Yeah. No, I got to my configuration point, but I can't remember what was in the page before. Let me go back and read that again. So anyway, after you build all of this and you've configured it, you now need to deploy that. And again, back in the old days, it was just one machine. You would deploy that thing on one machine. You would do a copy, but then that wouldn't copy your subfolder. So on the Windows machine, you used to have something like xcopy, and then if you were doing it remotely, you would do FTP, which stands for File Transfer Protocol. I know some folks weren't even born before that was around. But you're like, oh, damn it, I forgot a file. I forgot something, and it doesn't work. Why does it work on my machine? Why does it not work remotely, right? And thus came the whole beautiful aspect of Docker, right? Which is basically, if it works on my machine, let me ship my machine, right? That's essentially what we're doing. And it was a simple idea, right? It's like, okay, I have a whole bunch of things here, and I'm going to add these commands. I'm going to use this base image, and I'm going to add these commands to it. And, I'm going to deploy this. But of course, now we're not at the stage of just deploying a single service. Remember, we have to deploy multiple microservices. So Docker has a tool which is called Docker Compose, which says, okay, I'm going to compose all of these and deploy that. But no. You don't need Docker Compose. What you need, of course, is Kubernetes, right? Because why not? What is Kubernetes? I don't know, but you need it. Now, Kubernetes is a way, as it says, also known as KEYNOTE, is an open source system for automating, deploying, scaling, and management of containerized application. It makes containers to make up a logical unit for easy management and discovery until you encounter an issue. This is a true workflow to how to solve a problem with Kubernetes. Nobody understands it. There's a lot more going on under the covers. And of course, now you've got these containers, you've got the way to deploy, you're going to have to deploy it somewhere. And again, back in the old days, your own computer, living there. Then came a Heroku. Heroku was a great idea. I'm not being sarcastic. It was a great idea. If I'm doing Ruby on Rails, I'm going to be pushing to GitHub. Why don't I add another remote end that just publishes my work, right? Fantastic idea. Good idea. Cloud provider said, we can do the same thing. This is Google Cloud Products. Now, first you need to kind of figure out what you want, right? Once you figure that out, then you can start thinking how to actually use it. Now, I'm not picking on Google here, right? If we take a look at the next one, is Microsoft. Microsoft is essentially the same thing, right? You can just go through a whole series of things. One thing that really does stand out with Microsoft is that everything is free. And then you read the little star at the bottom. It's like, oh, not always. Now, I was going to do the same for Amazon, but the video was running way too long. So you can just scroll through all of the pages of Amazon and the services that they provide. So now it's reached a point where you have certification courses on learning the cloud. And to be clear, this isn't about, Amazon or Docker, or Google or Azure has this service, let me learn about it. No, this is primarily to learning what products you need to actually use and then figure out how to use those products, right? So it's not let me learn a product. It's like, here's a catalog of products. Take a course to learn which products are what and why you need them. And notice the emphasis on why you need them and not if you need them. So by the time you do that, it's all legacy, right? I'm using this service. I started to deploy. No, sorry, that's legacy. Now we've replaced that with another service. And of course, we've now entered the world of cloud native, otherwise known as vendor lock-in. Because how many of you create wrappers around your cloud services? Yeah, I didn't think so. I recently saw an article that had said, it was, I'm not going to mention the cloud provider, but it's one of the big ones. And they said, how we saved $50 million a year by migrating all of our in-house services to X. And about 3 years later, they said, how we saved $30 million a year by moving away from X. Now, of course, you need to monitor and maintain all of these things, so it's all about the DevOps. Now, the DevOps was basically a really, really simple idea by Patrick Debout, which was developers and operations talk together. They are aware of what's happening. They interact. What did we do? We said, no, tooling. We need tooling, right? And now you've got your infinite DevOps of possibility of all these different tools that you don't know what they're for. Fortunately, as a community, again, we've come together and we've created Scaled Agile DevOps Maturity Framework, or short, SADMF. So if you have any issues, you can kind of use that for guidance. Now, one thing I left out about all of this was security, right? Security is, let's talk about security a little bit. Now, security is complex, so generally we want to try and avoid it. And I'm not talking about the easy stuff. I'm not talking about authentication, authorization, all of that you can basically delegate to someone else and do it. I'm talking about this aspect of security, right? I don't know if any of you heard many years ago, one upset person decided to pull a package that they had on NPM, which was called LeftPad, which did a left padding, and it broke the internet, right? Because everybody used it. Now, fortunately, this was the code, actually. This was the code, okay? Again, as a community, we came together and we created leftpad.io so that it will never go down. I started to look at that when that happened, and this was a tweet from 2016. And I saw that there was a package that was called isArray that had 18 million downloads, 72 dependent packages, and it fits on a tweet. So that last two string, that's the package. And there's more. There is negative, is positive, is zero negative, is array, is not array, has identity crisis. There's a lot of packages out there in the JavaScript ecosystem. So going back to my website, which is static, I have all of these packages that are being pulled in, right? All of these for a static website. But it doesn't matter because in case I ever need it, it's there. In case I ever need it. Now, coming back to security, here's an issue. Did I examine all of those packages? Did I do an audit on them? Did I know if they're doing anything malicious? No. I just used it. I'm assuming the provider of those packages is not only a good person, but also where they're hosted is doing the verification and everything's fantastic. Oh, apparently it's not. Right? You probably all heard of SolarWinds and supply chain attacks. Yeah, well, that's happening every single day. Except some of them aren't that big. Constantly, vulnerabilities being found in packages, accessing data. We only find out about the big ones, but it's happening every single day. And this isn't a problem isolated to NPM. You've got this with Docker as well. 9 million images. How many of you verify your images and see what's happening and what's in that image when you pull it down? Not really. Oh, I'll just do the official ones, and hopefully the official ones will be okay. And we don't even care about versioning these things, right? Like, again, back in the old days, I know I sound like an old man yelling at the cloud, but back in the old days, we used to have a version control system where we used to check in everything, and we used to actually build on a specific version. Now we pull down the latest version in the build process. We're like, oh, screw it, it doesn't matter, we'll just, do it. And procurement, hopefully, is on the job. Like, as a vendor, we've been getting tons of questions, like any other vendor, about, we need you to fill out this form, right? It's a security and supply chain questionnaire. And how does this go? This is basically someone in procurement that has no idea what they're doing, is given this form and said, before you can buy something from this vendor, tell them to fill out this form. So we get conversations such as this. We want to make sure that the software doesn't use Log4j. Well, our software is .NET. Okay, but does that mean that it uses Log4j? Well, it's a completely different platform. Yes, but does it use Log4j? No. Thank you. Great. And then we talk about supply chain attacks. Like, literally happening all day. And it's going to get better, though, right? Because we've decided that this drowning in complexity isn't enough. It's not enough for us to drown ourselves. We're going to get those users to also get drowned as well, right? Cookie processing wasn't enough. Giving your consent and going through all of the options wasn't enough. We've now got Web3 appearing. And the promise of a fair and distributed web. Now, I don't know about you, but the whole idea of the web was distributed when we started this thing out, and it still is. And they're like, no, but it's in the hands of a few. Yes, and you know what? Web3 will end up in the hands of a few as well. Yeah. So, but it's blockchain, so it's probably good. And they say, no, cryptocurrency is going to not succumb to those corrupt governments, and you can buy your NFTs online, and man who paid 2.9 million for NFT lost it. If you're interested in Web3 and the FIRE thing that it is, follow this account. So in summary, what is my point? What is my point in all of this talk? Well, I don't have much of a point. But you can't blame me because I gave you the disclaimer. If you're here to learn, you're not going to learn. But there is some things that we can do. Like, again, think about what is it that we're actually doing and why are we doing it. So we read blogs. We all read blogs, right? We go to conferences like this one. And we listen to thought leaders tell us about things that they're doing. And we think to ourselves, well, I want that. I need that. And we kind of forget the whole context, right? Whereas for them, for their specific context, it might make sense. For us, it may not make sense. So just because Netflix uses microservices and performs Chaos Monkey doesn't mean we all need to do that. Just because Uber switches from MySQL to Postgres doesn't mean we all need to do that. In 2013, Uber wrote a paper migrating Uber from MySQL to Postgres. Right? I clearly remember this paper because I had folks, I was doing, helping some folks with some work, and they're like coming to me and they're like, oh, look at this. They're going from MySQL to Postgres. Should we do it? I said, no, why? Fortunately, it was good because in 2016, Uber Engineering switched from Postgres to MySQL. And yet, time and time again, people are like, oh, they're doing it. They have this issue. I may have this issue. No, you don't have 10 million users. But I could. Right? I could, and maybe if I switch, I would. But your market is only 10,000 users. I know, but imagine the possibilities if I switch. You can't even scale selling products. I know, but it's really, really cool. And of course, we've got the same with microservices, to microservices and back again. Because yes, I did everything in microservices, I put in all of these DevOps, I did all of these tooling, and now it's just a pain to maintain, and I haven't really gained anything from it. And yes, microservices is bad, and monoliths are good. And of course, all of this has other side effects that I think all of us as developers have suffered, which is analysis paralysis, right? So when you start a new project, you're like, okay, should I use ActiveMQ or RabbitMQ? Should I use DocumentDB, or should I go with a relational model? Should I use microservices or monoliths? What patterns should I be using? Now, what architecture do I need? And that's because we're focusing on the what and not the why. We're not saying, okay, why am I doing this product? Why am I doing this application? What are the needs? And we're starting like, what technology should I use? And you beg the question, like, why do we do that? I do it as well. I've done it as well. Like, what technology should I use? Should I use ActiveMQ? And you wonder to yourself, like, why? Are we focusing on CV-driven development? Right? If you look at CVs, we've ended up in this horrible cycle whereby we think that we're essentially things that can learn X products, and that's it. You look at your CVs, you look at other people's CVs. How does it come? Developer, 5 years, knows AngularJS, React.js, Android, blah, blah, blah. So what do? We filter on technologies. We don't filter on developer, solved this specific problem, did that specific problem. We don't focus on that. We focus on the technology. And we encourage it by not only promoting our own CVs with technology, but by hiring based on technology, as if people can't learn new things, as if we have a limited capacity to learn new things. So we're driving this. We're driving it by focusing our CVs and our personas by just knowing X, Y, and Z frameworks. Or you say, no, am I knowledge-driven development? Yes, I am. I mean, I've done it. Yeah, I want to learn something new, or I'm like, I need a new tool to help myself do something. Oh, I'm going to use RabbitMQ. Why? I've never played with it. It'll be a good opportunity. Okay, fine. If I'm paying for it, fine. If someone else is, maybe it's not. So you have to ask yourself, like, do you really need all of these things? And more importantly, does my customer need all of these things? Right? But you say, no. This isn't about what my customer needs now. This is building flexibility in mind. That's what we're doing. We're building with flexibility. We're building for change. We're building a clean architecture. Now, what's clean for you isn't clean for me, and isn't going to be clean for the next person that comes. So then, first of all, what is a clean architecture? Is it the solid principles that have been debunked? Is it the Cupid principles that are debunking the other one? What is a clean architecture? It's in the eye of the beholder. But yet you're like, no, we're doing this for change. But that change and that clean architecture, please, I'm not saying go around and write spaghetti code, because first of all, nobody knows what spaghetti code is either. It's just really horrible. But that clean architecture also comes at a cost. That scalability, that flexibility comes at a cost. Right? I'm going to implement everything via interfaces. Why? In case tomorrow I have a second implementation. Well, when you do, refactor it out. You don't need to implement 300 interfaces. I don't implement them. No, the IOC container takes care of it. Oh, okay. So you've basically got an IOC container that uses the default implementation for everything because there's only one implementation for everything. Yes, but one day I may need it. Right. But all of this comes at a cost. When we're looking at the code bases, when we're reviewing things, all of this comes at a cost. So you have to ask yourself, how many times have I actually needed all of this? And yes, sure, there are complex systems in the world. There are. I'm not saying that everything is very, very simple. But why do we have this urge to solve complexity by complexity? It's like we take pride in complexity, right? It's like, oh, no, this is complex. It's very hard to understand. I'm the only person that understands it. Brilliant. I'm so smart. No, we should aim at trying to simplify things so every colleague that joins a team understands it. We need to move back to simplicity. We need to move to simple solutions. And of course, that's not an easy task, and we're influenced a lot by external factors. But we can try and strive to abstract things by simplifying them. Right? We can make the lives of our users easier and simpler, but we can also make ours. We have so much focus on saying we're going to create an application that makes the user aspects, user interactions, user experience so much more simpler. Why don't we apply that same concept to ourselves? Why is it that we feel that we have to go towards complexity to develop solutions? Why is it that we have to bring in all of these technologies from day one because we think that we need to? So strive for the simplest solution and strive for simplicity. And I'll finish off with, you don't, as the saying went, you don't want simplicity because you can't handle simplicity. You need the complexity, you want the complexity. We use acronyms like YAGNI, KISS, and DRY. We use these as the backbone of a life spent designing with simplicity in mind. and you use them as a punchline. I don't know if anyone's seen that movie. Thank you.
Thanks, Hadi, for coming. Always a blast. I remember a couple years ago, just speaking of complexity, when Hadi actually was here doing a keynote at droidcon London on functional programming, and I think I felt like I was winning on that day because I understood about 20% of the talk. So thanks, Hadi. Again, round of applause.